Chapter 4 is congruent polygons and eventually getting into proving triangles congruent. Start off by copying over these few definitions here at the beginning. What is congruent figures? Congruent figures have the same size and shape. Congruent polygons, filling in the blanks here, have congruent corresponding parts, those being the sides and angles. And what I'm going to stress here is the naming of congruent polygons. You need to make sure that you list corresponding vertices in the same order. Vertices refer to the angles. Just by looking at the names of the polygons, we create the congruent polygon names become a congruency statement. A congruency statement tells us how the polygons are related, and just by looking at a congruency statement, you should be able to make additional congruency statements stating the congruent corresponding sides between the two polygons. You should also be able to make further congruency statements like these to show which angles are corresponding and congruent, as shown here. All right, we're going to take a look down at the example. The example is just another one very similar to the one above. We are given, not only are we given the congruency statement, we also have a picture of the congruent polygons over to the right. It may be most helpful to look at the congruency statement to list these corresponding parts. You can look at the picture, but you do got to be careful. If the pictures are not drawn in the same orientation, you need to think about how it may need to be turned or flipped to match up. So being that these are four-sided polygons, we're going to have 4 pairs of angles that correspond and 4 pairs of sides. I'm going to use the congruency statement here to help me out. I can tell that angle H is congruent to angle L. Angle I is congruent to angle M. Angle J is congruent to angle N. And finally, angle K is congruent to angle O. We can also list the sides. I'm also going to use the congruency statement. I'm not even going to go over to the picture. The sides, I can tell that HI is congruent to LM. IJ is congruent to MN. JK is congruent to NO. And finally, HK is congruent to LO. So you could look back to the congruency statement and see how I came up with these congruent corresponding sides. You could also take a look at the picture a little further, but I'm going to keep moving on. There is a try again. You should try this one. If you want to pause the video and draw these triangles, you can, but drawing these triangles are not absolutely necessary. You could simply use the congruency statement. Being that these are triangles, we should only expect 3 pairs of corresponding congruent angles and 3 pairs of corresponding congruent sides. Right? The next problem I've also started out for us, so if at any point you need to pause the video to copy over, you could. This is one where we may have to find a missing angle measure based on knowing we have congruent polygons. In this case, we are told that the wings resemble congruent triangles, and we're asked to find the measure of angle D. We can see the way that the triangles are drawn. The corresponding vertices are what matter to us here. Angle B is equal to angle E, which is equal to 30 degrees. Angle C and angle F are corresponding vertices, so they both should measure 75 degrees. And matching up angle A and angle D as corresponding vertices, they will be equal in measure. We can really find either angle A or angle D. Since we know the triangle angle sum theorem, I'm going to find the measure of angle A using the triangle angle sum theorem. So angle A plus 30 plus 75 should equal 180 degrees. The three angles in a triangle sum to 180. And in finding the value of angle A, I can subtract both of these from 180, right? And I end up with 75, right? Being that A is 75, and we know that angle A is congruent to angle D, that would also mean that the measure of angle D is equal to 75 degrees. So using what we learned on the first page about corresponding parts of congruent polygons, we can find missing angle measures. Right, there is one to try. You could pause this screen. You could look at what I wrote down as far as using the congruency statement. You should have this one complete when I check in on the notes. All right, so I'm going to go to the next one. You could pause and try this one and get that statement written down. But let's go on to another type of problem. We really start to focus in on polygons as triangles a lot in this unit. So one of the things right off the bat that you need to realize that if triangles are congruent, the definition of congruent triangles is really this that I wrote at the top. Triangles are congruent if all pairs of corresponding angles are congruent and all pairs of corresponding sides are congruent. So if we want to justify that these two triangles are congruent, we need to justify by using the definition of congruent triangles. So you may want to take a moment. I would expect to see this written down in your notes when I check in on the notes. There's a lot of things that are marked congruent already in the picture of these two triangles. We also see some side lengths in here as well. There are also a pair of angles here that are not marked congruent. However, they should be recognizable as an angle pair we've learned before. I'm almost going to set this up as if it's a two-column proof, but I'm not really going to make the statements in reasons column, right? I'm going to start off by making sure I have three pairs of congruent sides. So side AB is congruent to side DE. I can see that from what's marked on the picture, so I'm going to say this was given to me. I also see that side BC is congruent in length to side CD. And again, both of them were length 4, so that was just given to me. Finally, for sides, AC is congruent to CE. Both of them were length 6, so I'm going to say that was given to me in the picture. All right, let's move on to the angles. Angle A is marked on the picture as congruent to angle E. Again, that's given. And we also know that angle B is congruent to angle D. It's given to me. I need to list one more angle pair. It's not marked quite yet on the picture, but it should be recognized. However, I am going to have to name these angles here that are a pair of vertical angles with 3 letters. So I would have to say something like angle BCA is congruent to angle DCE, as long as the C is in the middle. And the reason is that they are vertical angles. So you could say vertical angles theorem, you could just say vertical angles congruent, either one would be fine. Overall, my answer is to justify that triangle ABC, now if I name the first triangle, triangle ABC, I have to be careful of how I name the second triangle because their vertices should show corresponding vertices. So I went ABC, so I need to go EDC, right? And the reason is that all corresponding parts are congruent. You could also say definition of congruent triangles. That would be appropriate. All right, so you might need a minute to write that down, or you might already be ahead and looking at the next theorem, which is what we're going to do. There's this theorem called the third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. Right? You can fill in the if-then part to the picture and kind of read back through that, pause the video if needed. Here we go with the last example. And then there's going to be a problem on the next page that you should complete. I will be checking in on that. This is a two-column proof. We're given information. We're asked to prove that the triangles are congruent. Based on where we are now, we talked about up above in problem 3, what is the definition of congruent triangles? And that's really what we're going to be using to prove these triangles congruent. I need to show that all three pairs of sides are congruent, and all three pairs of angles that are corresponding are congruent. I'm going to start off with my given information, and you can just put all this given information in one. You could put just the sides in one statement and then the angles in another. There is a little bit of leeway, but you do need to copy over all of that information that was given to you to start off the proof. The other thing here, not only do you see them written up above, you also see these same markings over on the picture, right? So pay attention to the markings that are there as well. Right, so I'm just copying over what I see up above. And if we're grouping it all together, it allows us to put our reason number 1 is that all that information was given to us. There's no other geometry backing for it other than that it was given to us in the congruency statements or in the picture over here. The given information has identified 2 pairs of congruent sides. What about our third pair of congruent sides? Right, I'm going to mark this segment LN right there with 3 slashes, right? And I'm going to say that segment LN is congruent to itself. When the triangles share a side, those sides are congruent to each other, and this is the reflexive property of congruence. I also need to show that a third angle is congruent, right? And that would be, I'm going to mark them in a different color, right? 3 slashes, little arcs surrounding this vertex at N, right? So I do need to name this with 3 letters. So angle ONL is congruent to angle MNL. And the reason that they are is the third angles theorem. Right, and that's the theorem right up above this example. I now have shown that all 3 pairs of angles, all 3 pairs of sides that correspond are congruent, so I can now have justification that the triangles themselves are congruent. So I'm just rewriting what I'm trying to prove, the congruency statement for the triangles. And I'm going to say my reason is definition of congruent triangles. All right. So there's your example. You should turn the page, and I would expect to be seeing this one attempted. Follow the one prior. As a hint, you know, there's a couple different reasons that you could use. I do see that it looks like a pair of vertical angles is present, and it's likely you're going to be using the third angles theorem again. Go ahead and try it.